Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about Edison Motors. So let's dive deep into it. Now, Edison Motor is a company that is specializing in vocational truck. What does vocational truck mean? Vocational truck simply means not your average truck, is specifically tailor-made tools. Meaning, if you have a garbage truck, that would be classified as vocational truck. If you have a food truck, it would be designed as a basically vocational truck. There are different laws, regulation for vocational truck because it's a very custom job. So whenever you're talking about something heavy lift truck, basically things that are designed to pull heavy loads, they classify as vocational trucks. So what is this truck's aim is? Basically these people, the CEO and all that jazz, they were working in Canada and they were working in specifically in logging industry, meaning going on top of mountain and chopping down giant trees and bringing them down. So logging was their bread and butter. So they had an understanding of what logging industry needs. So they directly built that. Now, why this truck is so unique? Well, this is the first time I've seen anybody using brain, and they had serial hybrid electric vehicle. Now, be mindful, parallel hybrid exists. That's what your kinetic energy recovery system is in F1. But here's the problem. Car companies, they took what works in F1 and they tried to force it into commercial vehicles, a common people vehicle. Yeah, that's the stupidest thing that can be done simply because F1 requires a whole engineering team to make it work. A normal vehicle does not have that luxury. So it's much better. It's serial hybrid electric vehicle. Is there any use of it? Yes. Every single locomotive literally uses this technology. So it's a very known technology. Thankfully, somebody figured it out. Hey, what if we add battery and put it on wheels? So serial hybrid electric vehicle. It's a privately owned company and they're manufacturing electric semi-trucks, and this puppy was announced in December 2021. Now, from announcement to actually having a vehicle that other people are sitting in and actually driving around, not driving around as in like actually they bought it and sold it. No, this is just first prototype. It was damn quick. It was like, holy damn, that was quick. Like Elon Musk could make 70,000 promises in that time and not deliver one of them. And they actually did it. That was like, whoa. Be mindful, Elon Musk announced a Tesla truck in 2016. So Edison Motor is going fast. So what's the logic behind it? Logic is very simple, as simple as it can be. First, you take ICE engine, internal combustion engine. Does it need to be diesel? No, they chose diesel because they know what it works, and like diesel is a very work fuel kind of situation. So diesel it is. Can it be replaced with other things? Absolutely. But they chose diesel for first prototype. And of course, the first range of vehicles would be diesel only. And then they're going to offer other options like CNG and other things like that. So you start with ICE engine. ICE engine does not drive transmission. This is the critical aspect. It touches the generator only. The only output from this puppy would be electricity. Now, is that important? Yes, that's the primary reason why hybrids failed in normal market, because nobody had the brains to like, hey, do this. What they had is like, hey, this goes into your wheels, this also goes to the wheels. It's like that was the concept of parallel hybrid. Benefit, it gives you more power. So if this is like, let's say 500 horsepower, you can have 1000 horsepower because the generator can act as a motor and dump that energy. Short duration. And again, it makes your lightweight engine act like a very heavy weight, but complexity goes through the roof, and you have clutches. You have clutches because of that stupidity. So this company is like, hey, simple generator coupled to a simple generator, as in like internal combustion engine generator. Now, why is this important? This makes sure this will only run at 1 RPM. It starts off, it goes to that RPM, done. Now, is that important? Yes, for two main reasons: emissions and mileage. Emission simply because the NOx emission is really hard to control if the RPM is changing. Meaning, if you have this system, you will require a giant computer system, which, be mindful, yes, majority of modern computers have like lot of computational horsepower in driving electronics, whereas like, okay, accelerator is this much, this should be the flight profile, this should be the profile of fuel injector, this has to be, lot of computation has to go. Here it's like, dude, 1500 RPM, done, go home, sweeter. Whatever RPM they choose, but it's 1 RPM. And the NOx emission goes down, sulfur emission goes down, everything goes down, the mileage goes up. It's good for environment to have an engine running at 1 RPM. Then they can fine tune everything to work at that RPM. Generator fine tune to work at that one system. So they have internal combustion engine, generator, and then power goes to battery, and then battery drives the motor. So it does have regeneration. Now, regeneration is very important for these folks. Why? Well, these folks, they have the very unique job of taking an empty truck, going on top of mountain, collecting the wooden logs and bringing it down. Now, you must have noticed there is energy there. Yes, there is energy. So what they do is they charge the battery, and yes, it can be charged from outside. Yes, it has system, but it's not requirement. Requirement as in like you're gonna have it, but like if you're like, hey, I'm only doing it once in a while, here and there, you can directly run on electric only. So what they have is like they charge the battery, go up to the mountain, bring it back, but because it is so heavily loaded, basically they went up around 12 ton, came down at almost 60 ton. They're like, hey, regeneration, do your magic. So they charge the battery, they got more energy, and they dumped the load on the surface level, went up again, and now they are literally running on free energy. Can this be done? Yes, there are many trains on this planet that does this, but it has to be very unique circumstances where you always have a train that is coming down a very steep grade and going up empty. If that can be done, it can be done. So that's why regeneration is very important for them. Now, did they achieve 100% free energy? No, they only managed around 50%. Now, is that 50% significant? 50% fuel saving? 50% fuel saving for their workload translates to shut up, take money. So ICE engine, generator, battery, motor, it has regeneration, and prime source can be anything. This is the interesting aspect. This is diesel generator as of now. It can be changed for a case of India, which I do expect India to wisen up in future and utilize our resources. This puppy, the things come out of there. Why? Biogas. What is that? Methane. What is that? Clean burning fuel. What can we do? Drive trucks with it. So this can be replaced with CNG. Delhi, basically upper India already has CNG infrastructure, so it won't even be a big thing. And once we start to use biogas, it won't even be carbon polluting, it will be just carbon neutral. So CNG good. LNG, again, some companies do try LNG, but I don't see much use, but it can be done. Then the stupidity of hydrogen. Now, again, if you have seen my videos, you know why hydrogen is stupid, but just in case you have not seen it, simplest condensed answer of that, hydrogen does not have energy density. What does that mean? That simply means if I give you liquid hydrogen, the highest density of liquid, basically density of hydrogen you can practically have, it only gives you 8 megajoule per liter. What does that mean? That simply means if your diesel engine, this puppy, is taking energy from your fuel tank, let's say 50-liter fuel tank, and it's giving you 21% efficiency to the wheels, meaning it is consuming fuel. If it's 40-50% efficient, forget about it. It's not even a competition at that point. If it's giving you anything above 21% efficiency, you have to extract 100% out of hydrogen, which cannot be done by laws of physics. You cannot be 100% efficient. And God help you if your diesel is more efficient than that. If your diesel is, let's say, 35% efficient, which mind you, normal trucks can do, yeah, good luck with that. You have to exceed hydrogen, liquid hydrogen. And be mindful, compressed hydrogen is half of this. So if you have 300 bars, it's very low power. If you have 600 bar, some power. Liquid, still no power. So that's the reality of it. Hydrogen cannot be used. And I'm genuinely shocked how bad our education system is that nobody figures this out. And ironic, given the fact that we have tried all of this in 1970s. People built trucks, people built cars, people built planes, people built fighter jets with liquid hydrogen, and they learned it the hard way. The hydrogen does not have enough energy density. Then it's like, why Boeing is building it? Boeing is not building it. They don't want to build it. Government is forcing them to. It's like because government does not study maths and they do not suffer the consequences of that stupidity. So plane has to have three things: mileage, basically how long it can go, the flight time; payload, how much it can carry; and the speed. You have to give up two of them in order to arrive a plane on hydrogen. They will do it, but people were like, why plane tickets are so expensive? Because we were smoking weed and we are not doing mathematics. Like, I have seen smart people talking about hydrogen as it's like it can be done. It's like, we done this. Liquid hydrogen is the highest. We are letting liquid hydrogen go in rocket industry. We are like, yeah, you're not that good. We are going into methane. And people are like, hydrogen is the future. It does not have energy. It has to be bounded to carbon. Only then it has enough density to be useful. 38.6. Then why the heck people say hydrogen has density? Because people are stupid and they do not understand the difference between liters and kilograms. It's like you have to have almost around 11 liters of liquid hydrogen to have around 1 kilo of it. What would be the size of your tank? And compressed hydrogen, don't even go there. So that's why. Two practical options, you can have diesel and you can have CNG. CNG, I really see some serious potential because again, we do poop out a lot. And if we start collecting all of them, we're going to have a carbon neutral source of CNG. So might as well use it. So that's good. Battery capacity. Now this is where clever part happens. The battery capacity and weight is low. Why it's low? Well, they do not need very huge one because they have a backup. So this is a very wise system because everybody will open their mouth and it's like, I want 10,000 kilometer range. Yes, dear. Do you really? Like in car case, not majority of people don't even need more than 50 kilometers. But let's say you give them 100 kilometer, because we are comparing sizes, everybody's like, no, mine's 200 kilometer, mine's 400 kilometer. It's like, every time you increase battery capacity, you reduce your efficiency because your vehicle is now heavier. It's consuming more megajoule just to move itself without any payload. So having a smaller battery is far more efficient, meaning if I give you 1 megajoule in this puppy, how far this will go compared to if I give you 1 megajoule, same technology, but they just double the battery size, it will be less. So battery is very small, weight is very low, minimal, and their target was to keep this truck more or less the same would be the 8-foot diesel. Like if you take diesel equivalent horsepower to this puppy, same. And it is also easier on the grid. And this is another aspect you have to understand. Trucks consume power like there is no tomorrow. If you can you drive these things with electric motors? Absolutely. But it would be literally like running locomotives, like small locomotives. These puppy consume boatload of power, and they do not have the luxury of locomotives, metal wheel on metal rails. It does not have that luxury. So the power draw on these puppies, just saying that, oh, we're just going to have a hypercharger. It's like hypercharger requires 1 megawatt minimum per link. That's not happening. Like right now in India, in Canada, in Australia, in USA, many countries, we are denying solar system because we do not have grid to connect them. And you are saying, oh, in this middle of nowhere, now we're going to put megawatt charger. Yeah, that's not happening. Not like, stop doing this, man. That's not happening. So it's much easier on the grid. So the smaller battery, they can charge it. And if it's not available, they got their own source. So that's the logic behind it. So what about the philosophy? Now here's the, many companies can do amazing things, but they only look amazing on surface level. Once you really deep dive go into it, it's like, dude, it's garbage. So here the philosophy is they're giving you best of both worlds. Internal combustion engine gives you the oomph, the power, the range. So they are like, hey, we have that. Now EV gives you efficiency, noiseless performance. And yes, that does matter because there are laws in place for basically residential area that you cannot have a truck going there. Why? If truck has to apply brakes and heavy brake, it will do Jacob braking, meaning the diesel engine will behave like an air compressor and it will make sound like very bad sound. People hate it. Truckers love it, people hate it. And EV, if you're doing regen, no sound. So it gives you best of both worlds. So it gives you the range of basically internal combustion engine and recharge of electric, basically internal combustion engine, while EV gives you all the efficiency related to it. And it's built like a simple road tank. I cannot tell you, like I have seen teardowns of electric cars. You would think it would be simple. It's not. You would be shocked how overly complicated those things are. Like you look at the, like you have to remove this upholstery, you have to remove this part, then you have to do this, and then you find this small charger. You're like, what the hell? This is very simple. Everything is designed by people to be serviced by people. It's very simple, and it's like tank-like robustness. The design is inherently like a diesel locomotive with battery. That's it. That's the only difference between this and a diesel locomotive. Diesel locomotive does not have batteries. I know they do have small battery for running one inverter for small shunting duties, but that's not this. So in terms of their chassis is bolted. Now why bolted rather than like, just welding? Here's the, if you have metal, no matter how strong it is, no matter what alloy it is, no matter how thick that puppy is, sooner or later it's gonna crack. Meaning if you build this puppy and you drive this puppy 10 years in and out, there are places there will have suffered what we call fatigue. Things will crack, things will break. If you have welded them, you have to cut them out, which will be very difficult. If you have used fancy torque screw just to F the customer will suffer. Here they are like simple bolts, take it and go. Meaning if you ever want to rebuild the chassis, which again, these things can last for 50, 60 years. And yes, people are using something that old. You could simply be like, hey, 10 years is up. Let's just strip down everything. Let's make sure, because rust is one of those things that you cannot recover from. You do want to, like, let's strip down everything, repair everything, polish everything, hunt down even the smallest spot of rust. And then you're like, you're good. So bolts make it very viable. Then we have rubber steel airlines. Now this is shocking. Again, India is not went to this level, but we will, that we're going to replace metal rubber coated structure with plastic pipes. Now you're like, wouldn't this have more carbon footprint? Yes and no. Does it have more carbon footprint while making them? Absolutely. Does it have more pollution? No. Why? This will last for decades and decades and decades and decades, while your plastic system, 1 decade, psh. Second one, yeah, 5 years, psh. You keep doing this. That's why, like, it's one of those things that once you get older, you understand. Like, you buy cheap, you buy twice. You buy expensive, you buy once. So using rubber, steel, airline, and they are also giving slack, meaning if joints do crack. But again, I told you, no matter which metal you have, sometimes something will break. They're like, hey, you cut it open, splice it, put a new joint in, you're good to go. Awesome. No curved classes. Thank you. It's like, I have no idea how the heck somebody smoked enough weed where our bulldozers nowadays, cranes, excavators, they have curved classes. It's like, it's about aerodynamics. How fast have you seen a tracked vehicle go? And like these things, they generally have things behind them. And that thing is generally a brick of aerodynamics. And if it's a logging truck, it's really bad in terms of aerodynamics. Do you really think it will make a difference? No. Then why does company do that? Well, company wants to F the customer. Because here's the deal. Now, if I give you a curvy glass, which mind you, companies do not even standardize it. It's not like, okay, MAN trucks, they have only this one curved profile, the end. No, no, no. Because again, if they did that, other third parties will figure it out how to make it. And then they're like, no, no, every model is different. And then something bad will happen. Something will crack. And then you're like, companies will be like, yeah, $10,000, my man. We're gonna F you. Plate glass, $100, take it and go. Don't worry about it. Heck, you can even put some spare. Like if let's say you have a fleet of these trucks, you could literally have spares of it. So super subtle thing, super awesome. And again, if it has to come to India, I think it will require infrared coating. But again, it can be done. Flat glass, done. Fault codes. I am genuinely shocked how the heck technology never progressed beyond 1990s. If in 1980s you built an electronic computer in your car, which every car has that, it had a fault code. Okay, awesome. Here's the fault code could not tell you anything. It was just tell you a number. Why was that? Well, it was that because we did not have memory. We did not have enough megabytes in the chip where we can store text description. Like literally, we had to store that much. Like that is the era of floppy, 1.5 megabytes. So what happened after that? Well, now we have gigabytes of memory. This is the only company I've seen that as like, hey, we have gigabytes of memory. What if instead of effing the customer, we tell the customer, it's like, hey, hey bro, this is broken. Now it will give you a code. Again, it will not mean anything to you, but it will give you a description. Now we have the technology of memory. We can have 1 gigabyte. We have the memory and it will say, okay, your inverters are overheated in this inverter. This is what troubleshooting steps you can do. Hey, your generator has overheated. Can you please, let it cool down for a few minutes again? Better to cool it down than to burn it up and then be like, yeah, now it's an expensive repair. Fault code, which actually tells you. It could have been done as early as 2000s, but we never did that. This company is like, hey, Apache is doing it. So I'm very happy. Fault code, like this is what I said, like philosophy of this company is genuinely good. Now, enough space for real servicing. This was shocking to me. And I would urge you to watch electric vehicles tear downs. You will be shocked. You would think like electric vehicles, simple things and all that. You will be shocked. Like you will be horrified how difficult it is to take them apart. And they just assume that you're going to throw it away. Again, if you are rich, you could throw it away. But if you're not, then what? This company is like, hey, this is expensive. We want it to last forever. So everything is put in space. Like this is how inverters are here. Now you might be saying like, okay, this is a truck, big enough space. Yeah, there are other electric trucks also. Please look them into it. Please look them into it. Good luck. You'll find like nobody thought about repairing. And again, why the heck those are designed that way? Well, so they can, F the customer. They're like, hey, you can't open this, you can't touch it, you have to bring it to our service center so we can F the customer. Here it's like, bro, they can literally phone you. It's like, I think your inverter number 4 is gone. Just do this, take it and go. That means awesome things. And here's another benefit. Imagine you are driving this 40 years from now. And again, truck's structure is built that way. It can last that long. Motors do last that long. So what if it's like, hey, inverter, we have much better inverter. So let's say this is 95% efficient. What if you replace it with a new system? Which has like, let's say 98% efficiency. Shut up, take money. Space, future scope, future growth. And the other sides are the bus bars and all that. And the company that developed the bus bars and all the power electronics, they're like, yeah, they work with Subway. So they know how to design something that survives a vibrational environment, high voltage and serviceable. So really wisely built. Like a human hand can touch it, human hand can repair it. So really good. So what does this mean? This simply means their philosophy is very simple. This puppy will last you a lifetime if it's maintained. Meaning, as long as you can keep rust away from this, nothing inherently should go badly into them. Where it's like, yeah, this is a write-off. Unless you like hit it with something very bad. And be mindful, this thing is so overbuilt. Even if you hit a tree will go down. This will not go down. This is a heavy puppy. So philosophy wise, really good philosophy, and everything which I'm seeing is awesome. So now come to the economics part, which is the most important part, because you have to understand physics, engineering, economics. If economics is broken, it will not work. So what are they giving? Because the truck is more expensive than a just Control-C, Control-V diesel truck. So why? Well, truck is the cheap part. That's why they can sell it. Now, like why the heck truck is, which is a very expensive unit, why the heck that is cheap? Well, it's even if this truck, which is a hybrid system, is 50% more expensive than equivalent diesel truck, they are saying it's 0.30%, like 1.3%. I think it's a 1.5x. Why did I say percent? That's the whole point. So even if it's 50% more expensive, if it has low TCO, total cost of ownership, people will simply say, shut up, take money. So if you can visualize it, think in this way. If you have a truck, it is spending a lot of money in maintenance. It is spending a lot of money in fuel, bonkersly large amount of money in fuels. And it is, basically, if lifespan, like if it's designed to be thrown away like every 20 years, you are throwing a lot of money buying a new one. And basically the salary of the drivers, again, that's also costing a lot of money, and replacement of parts. Be mindful, whenever you see this, basically brake pads and being removed, it's costing them twice. It's costing them one in terms of downtime, because the truck is not making money, and it's also consuming money while you are replacing things. So downtime, fuel cost, maintenance, all of these pile up exponentially. So a truck that is expensive, it's free. It's free. That's how insignificant the cost becomes. So if you can guarantee a company, let's say a company that is running 100 trucks, and you go to them, it's like, hey, this is our truck. We guarantee this puppy will save you 10% without a doubt. Like you run this puppy 1 year, run our puppy for 1 year, we're gonna give you 10% more savings. Shut up, take money. 10%, if you can prove more than. And will it do that again next to a diesel system without electrical charging? Absolutely. Why? Again, engine is working at 1 RPM. It's far more efficient, and you have regen. Those two things combined alone is like done. It's not even a fair competition at that point. And then if you reduce downtime by maintenance and easily serviceable, they're like, shut up, take money. Oh, plastic thing where you just damage happen. Again, things happen, damage happens. It's like, throw it away. Here it's like, on-road maintenance, take it and go. People will be like, shut up, take money. So this is a critical aspect. If you can guarantee 10% minimum, which, be mindful, I'm reasonably sure they can easily exceed this. 10% is minimum. People will pay more for that. And if you can reduce downtime. Now, brakes are consumable in trucks. This I did not knew that. Like brakes are consumed. Like you eat brakes for breakfast. So how can you increase lifespan? Well, here's the deal. You take brakes, best of the best brake, whatever disc brake, drum brake, whatever have you. You go to the brake manufacturers and say, hey, I want to slow down a 60-ton vehicle from 60 kmph to 0. They're like, yeah, it can be done, not that bad. You go to the same manufacturer, same piece, and say 100 to 0. It's like, yeah, man, you gotta replace this puppy after like, this many cycle, 25,000 kilometers or something like that. Like, why? Yes, exponential heat increase happens if your velocity is higher. But if you have regenerative braking will never bring you to stop. It will never make your speed 0. But it can easily take your 100 kmph, drop it to 30. Now, if you apply drum brakes at 30 kmph, drum brakes are like, dude, you're boring me. Like it will not even erode at that speed. That's why your brakes will last much longer. Your chassis will last much longer. Heat generation would be much lower. And given the fact that everything is floating, your wheels just have one motor that is spinning mass. That's it, done. That axle. And you have isolated that completely. There is no hard rod connecting to a giant vibrating block known as engine block. Engine is also floating because everything is connected by wires rather than hard points. Everything is floating. Everything will have less wear and tear. So you reduce time, done. And commercial vehicles have different life cycle compared to a vehicle. So why do you think we buy so many vehicles? Because we don't use them. If everybody was using every vehicle 100% of the time, there won't be enough road, there won't be enough space, there won't be nothing where we're like, yeah, I'm not gonna buy a car because my car is actually driving at this point in time. We collect them, like it's almost a collectible for many people, and people cycle them like, oh, I bought this 5 years used, 10% of its life, and then we just throw it away. Most of the time is staying in the garage, staying in a parking lot. Commercial vehicle completely different. It's actually working 24/7. Some of them literally have what we call crew rotations, meaning you did back and forth for, let's say, shipping terminals to railway station, that has a very brutal work schedule. So you have back and forth, and then the person gets tired. It's like, okay, I'm out. New person gets in, same truck going back and forth, back and forth, back and forth, back and forth. So you can understand that it's a very, very different lifestyle for commercial vehicles. So you need something that can actually keep up. Electric simply will not. At that point, it will not. Unless you use lithium titanate oxide batteries, it will simply not. And even if you got batteries somehow, problem would be how the heck you're going to have megawatts of dumping power every few minutes. Yeah, good luck with that. So, and if you can make a truck that is easy to drive rather than requiring very loud. Now be mindful, truckers say they like it. Their physical body does not like it. Their physical body and their doctors is like, yeah, this job is literally not good for your health. And right now you must have seen a few years ago the news that USA is suffering from shortages. UK is suffering, almost came to crawl because of the trucker shortage. Canada also has that. Is why? Well, trucking is hard. Why it's hard? Well, there are many things that makes it hard. On top of that, the truck itself is hard. Truck itself is noisy, loud, vibrating, and on top of that, it has gearbox. God help you if it's a manual gearbox. Thankfully, more and more are getting into automatic. Still not that much better. And inherent design of it is very tough to drive. If you have electric smoothness to it, it's like, hey. And sometimes people can do what we call single pedal operation, where you regen is like how you slow it down and how you accelerate it. Most of the time, you can get things done just on that. People will do this much longer. They will be less fatigued, meaning how often they fall sick would be reduced. Your downtime will go down. So you will have less drivers quitting. That translates to more profit. And commercial vehicle in small numbers, yeah, that is factual driving. Like you will say, oh, this vehicles, we are selling hundreds of millions of cars. That's true, factually true. Commercial vehicle, barely 50-60,000 per month. But here's the deal. It consumes a national level fuel, meaning if you changed commercial vehicle in such a way that it directly saved, let's say 10% fuel, next fiscal year, government would be like, hey, why we have so much extra money? That's how big impact would be. Because these things work 24/7. They literally are big on fuel intake, like brutally big on fuel intake. So that's why total cost of ownership is far bigger deal than just like, oh, the truck expensive. No. Truck is efficient. Good. Truck is easier to drive, ultra good. Truck is long lasting, super good. So that's the whole point with this. Low total cost of ownership. So what we can expect in the future? Well, this truck is the only time I've seen a company building something that is made with wisdom of the user. I'm gonna use the damn thing. I have to design it such a way that I do not hate myself. So this is really, really good. Like you can see that engineers are not bad people, but if they are not in the field, which happens nowadays, back in the days, like people who was used to design vehicles, they were sometimes actually talking to the people. It's like, hey, you're gonna drive my truck. Hey, tell me, give me some feedback. That no longer happens. It's just like so disconnected. Like CAD models are designing the truck, and people who are using it is like, what did you design? And people who are repairing it's like, I need a manual just so I can remove the inverter. Like it has like, please look at electric vehicle tear down. You would be shocked. Like you need manual within manual with some extra manuals just to tear it down. So this is the only time where it's like you look at it and you know what you need to do. Awesome. And it has lithium iron battery. Now be mindful, some of you may have thought of like, hey, what if it's using lithium ion or lithium polymer? It goes boom, and that is factually true. Lithium iron on the other does not. Now what is the other benefit of that? Another benefit is it has more life. What does that mean? Batteries are counted in terms of their lifespan in cycles. So if you have lithium ion or lithium polymer, that will give you around 2000 to 3000 cycles. That is okay lifespan. Good. But if you compare it to lithium iron or lithium iron phosphate, you are looking into around 10,000 cycles. Exponentially longer lifespan, meaning they will have bearing replacement before the batteries are like, I think I'm getting old. So yeah, that's how long it can last. Then we have another aspect, power. What does power mean? Power simply means your tank multiplied by hour. So if you have tank is 100 kilowatt and you can dump 100 kilowatt in 1 hour, that is classified as 1D. Now, if you have 4D, that simply means multiply that with 4. So you can dump around 100 kilowatt, 400 kilowatt without harming the battery. So lithium iron phosphate gives you both of these. They give you a much longer lifespan, gives you fire safety, and gives you much more oomph. So you can absorb much bigger regen shocks, and you can dump much more oomph, where you're like, and this is another thing that you realize, that this engine is just not powerful enough to give you full range of acceleration that a truck requires. Battery is like, I got this, fam. So if a driver is trying to take over, which again they have to do for merging and all that, if they press the accelerator and let's say the generator is working full out, this generator is like, dude, I don't have enough power. The battery at that time is like, bro, I got this. Battery will go into 3C, or C, I'm saying 3D, and we're like, boom. And motors are like, I got this. You get the acceleration. Once you are in the cruising phase, it's like battery is like, I got this, you good? Generator will be like, yeah, now I have surplus, now I charge you. So fundamentally, you get a lot more oomph out of even a smaller system. Even though the horsepower there in the engine is much lower, the actual useful experience of the driving is like, oh, it's an 800 horsepower system. And is there any consequence? Yes. If you have this battery, it comes with some consequences. Low capacity, meaning how many kilowatt hour you have in one volume is much, much lower, like around 30% lower. Or some designs it could be even lower. And again, you can even get better battery than this, which is lithium titanate. It charges in like minutes. It's like the C rating of that puppy is bonkers, like 4C. 4C is 15 minutes charging. So that is very fast, but capacity is even lower and cost is even higher. So lithium iron is very good balance. Now, what this company is doing is what my personal desire is for this world. They are not waiting for magic technology. I genuinely do not know how the heck our education system is this bad that people are genuinely, we tried it, we built it, we studied this, we did everything with it, and then we're like, hydrogen is the future. Dude, 1970 is calling for you. Apollo mission had hydrogen fuel cells. We learned it the hard way. That is not a good efficient system. Now we are throwing all that away, putting it solar panels and batteries in Orion mission. Why do you think that is? Hydrogen fuel cell is dumb. So genuinely, like, we're gonna have this technology. Again, this company was approached by a hydrogen manufacturer. They're like, what if you do hydrogen? And flat out, again, they signed NDA, so they cannot directly say, but they're like, yeah, we looked at their fuel cell price. Yeah, no. If you have seen my hydrogen train video, you must know the same thing. It's like, toy train in India is costing same as a freaking 12,000 horsepower locomotive, or even 6,000 horsepower locomotive that is designed for wide gauge high speed operations, and toy train that is designed for 24 km per hour and few people inside them, because hydrogen. So, and like, again, plane was even stupid. Thankfully, I've seen at least 1 or 2 pilots that are like, yeah, bro, that's no. You can force it, you can make it. It was just like, yeah, your speed is slower, your range is lower, and your capacity is lower. So they're not waiting for magic technology. Like, what do we have? What are the tool set? They're not waiting for glass batteries. They're not waiting for sulfur batteries. They're not waiting for magical hula battery. They're like, what do we have? We have lithium iron. Let's go. We have diesel. Let's go. What do we have? Let's go with it. That's really awesome. So they are working today so we can have a brighter future. I have seen way too many companies, way too many people with this approach where it's like, in future we're gonna have glass batteries, in future we're gonna have solid electrolytes battery and blah blah blah, then we're gonna do this. Like, how do you know those gonna happen actually? Because here's the deal, they have the advantage that let's just say some new magical battery comes along, no problem, they can just swap the battery. They don't even have to worry about it. Like what about generator? It's like, let it be there. Just in worst case scenario, or let's say you have discharge it. Again, that could happen in vocational system. You will have that as a backup. And again, heck, you can even make it smaller. So just in case, if let's say that does happen, the dead load of that generator system goes down. So they're not waiting for magical technology. They are like, what do we have today? Let's go. That's awesome. Now, diesel for most people, that's obvious. CNG for India. India does have a very good CNG network, and be mindful, CNG is basically methane, compressed methane. Compressed natural gas. Natural gas is methane. Now, biogas is also methane. So, India has a lot of population. Even if we start to use our backside properly, India is going to have a boatload of methane. So, if we have methane, drive heavy loads, awesome. So, I can see CNG and diesel for most people. Hydrogen, I genuinely want to blow people up. It's like, who the heck is teaching science in our schools and now? It's like, we did this, we studied. Like, even rocket companies are like, yeah, hydrogen is not really that good. Like, it does have specific impulse. It's just our rocket becomes so heavy that it's like heavy because of this fairing and all that, and the tank size and the insulation. It's like, yeah, there's no point. And what can we expect in the long future? Well, seaweed biofuel. Why do I keep going back to this? There is nothing else. Nothing. I'm genuinely confused about this world where it's like, I'm seeing nuclear physicists like Thunderfoot is like, what if we use sodium? What if you use seaweed biofuel? What if you did what Rudolph Diesel and Henry Ford did? Henry Ford figured out that we need to use grow fuel, and he was using ethanol. Again, early prototype, really bad idea, but again, he started with growing fuel. Rudolph Diesel, oil. peanut oil. There was no diesel at the time of Rudolph Diesel itself. The diesel is named after the guy. How the heck that engine was working? Vegetable oil, cooking oil. That's why your normal diesel system can just run on vegetable oils without any issue. And again, we could have taken that. Again, be mindful, US government did put a boatload of money into research during oil embargo, around $4 million. It's like, hey, can we find a solution to that? Their outcome was LG biofuel. Now here's the, can LG biofuel work? Actually, yes. Will it work very large scale? No. Why not? We do not have enough fresh water. Here's the deal. What do we have? Infinite surface area and infinite capacity. That is C. Seaweed biofuel. It has lower yield compared to algae. So as in like how much oomph you're going to get per square hectare goes down. But you have infinite C. Not infinite, I know it's not infinite, but you get the point. Like it is more than enough. And we are not providing the energy. Sun is doing that. It's carbon neutral, and we can keep overproducing it, so it becomes carbon negative, and we keep extracting it, making it into crude oil, dumping it back into the ground. People are like, oh, how do we do carbon capture? Just undo what we did. So that's why long-term wise, and this again, this truck would be like, hey, I was there. Like this can easily survive 40-50 years. So I could actually see that. I hope someday somebody will bitch slap a politician who's like harming the population and it's like, hey, remember that you brain damage the humanity with hydrogen? Yeah, you die. So I do expect future, hopefully we're going to figure it out. And anybody who's saying, oh, it's expensive. Remember solar panels? They used to be very expensive. Once you start investing in it, it comes down in price. It will never come down in price if you wait for it. So seaweed biofuel for carbon neutral future, and this puppy would be there. It will last that long. And it can do one thing that you have to understand. Right now, no other technology can. It can do last mile delivery, meaning, let's say you have a bit far away, you have a giant shipping center. Awesome. Now that shipping center, you load up your truck, you go into a city, and city is like, hey, residential section, man, no sound, no problem. Engine turns off, you run on battery, and then once you start to come off, then you're like, hey, low battery, no problem. Turn the engine outside of the city. It can do that today. That's why I said, like, I'm genuinely shocked how people are like, what if we take the F1 technology and put it into normal vehicles? It's like, what are you smoking? F1 requires a team and it throws away engine blocks like they are depreciable. I was shocked they were throwing away 6 engine blocks, and then somebody told me, yeah, they used to throw away 8 engine blocks per season. So that's why, like this, I'm genuinely happy. And I really love the Edison Motor AF Tesla. It's like 2016, you announced something that you never delivered. This is 2023 and you still have not delivered. And like, I'm genuinely curious, at what point somebody's fake promises becomes a scam? Because again, you can promise it, we're going to give you fusion. It's like, how long should I wait? Because again, hopefully in future, 200 years from now, it happens. But would that be a scam today or not? I really want to know, like, how long, like in time, how long somebody's promise should be viable. Because again, if Elon Musk comes into a stage, says to people, in 2 years, we're going to do the delivery, stocks goes up, then he sells the stock to buy Twitter for some reason. And then companies like, lol, we don't actually have it. And then he's like, oh, we have autopilot, we don't actually have it. Oh, we have this, we don't actually have this. So how many times it has to be done before you say, yeah, that's a scam? Like Elon Musk is only going to go down as just one person who did one thing right, SpaceX, and he gave someone else the driving seat of SpaceX, different CEO, and then SpaceX survived. Everything else is just like lol. So I'm really happy with this trucking company. Really, really happy. It's like smart, hard-working people built it. And the speed they built it, damn. If they did not have that 16-month lead time required for the e-axle, they would have been like, bro, we done, we good, go. So I'm really happy with this people's approach, like really happy. No magical technology, no this, if this, then that. It's like, what do we have today? How can we make it better today? So this was my presentation on basically Edison truck. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.